the previous year questions on solid state physics. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So let us start. So the first question here is, in a BCC lattice with lattice constant A, the body centered position from the origin is at a distance of. So the solution for this question is goes like this. So as they have given, BCC means body centered cubic crystal. So the structure goes like this. Then if we take the corners A, B, C and O as the reference, then AO having the distance of 4R. R is what? Radius of the atom. Then if we take triangle OAB, then we can have the edge OA is equal to root of OB square plus AB square. In a triangle OCB, if we take, then OB is equal to, the equation goes like this, and OA will become, if we take triangle OAB, then OA is equal to what? Root of OC square plus including OB, that is CB square plus AB square. Then OC equal to AB is equal to CB, that is a lattice constant, the distance between each atom. Then if we take the triangle AOC, then we can have the root of A square. If we add root 3A, we will get, so then for OA is what? 4R is equal to root 3 into A. Then radius of the BCC structure, we will have root 3A divided by 4. Then cube of a body centered atom which has 2 atoms per unit cell, then 2 into R, that is root 3 divided by 2A. This is the correct answer. So here option that is root 3 by option C. Then next question, in a cubic crystal, the interplanar spacing of HKL plane is represented by DHKL. Which of the following is true? So if we take in a cubic crystal, the interplanar spacing that is given by D equal to A by root H square K square plus L square. So A is what? Lattice constant. If we take the plane 1, 1, 1, then we have A divided by root of 1 square, then that is A by root 3. Then if we take 1, 0, 0 plane, that is equal to A. 1, 1, 0, that is A by root 2. So from this it is clear that the value of which is bigger here among these three planes, that is D110 is greater than D111. So the correct option is here B. So next question, Madelung energy is calculated in. So among these inert gas, covalent, hydrogen bond or ionic. That correct answer is here D, ionic bond, because as we know, the Madelung is calculated for ionic crystals like sodium chloride, cesium chloride, zinc sulfide. So the correct option is D. The next question, the total potential energy of a pair of inert gas atoms at separation R is given by. So the correct answer here we will get from this equation. So the negative gradient of potential energy, we called it as a force, that is F equal to minus dV by dr. If we take the derivative of this given equation, potential energy, then we will have force equation like this. Then positive sign indicates the repulsive force and negative sign, that is attractive force. Then the repulsive force here is the term 12B by R to the power 13. So the option B is correct. Okay. Next question, in a crystalline solid with n number of unit cell, the number of allowed independent phonon modes of a branch is. So the answer for this is, for n unit cell there are n different value of k wave vector for each cell, that is n independent mode of oscillation. Then the option A is correct here, capital N. Okay. Next question, heat capacity of a metal is measured as a function of temperature T in the low temperature region. Assume that the measured specific heat is due to both electrons and lattice. Then the plot of CV by temperature T versus temperature is, so among these options we will have, at low temperature heat capacity is proportional to cube of that, CV is directly proportional to T cube. Then if we have the plot of graph, we have the linear variation of this ratio with respect to temperature. So then CV by T is directly proportional to T square. So the correct option is linear in T square. So the next question, in a metal A and B, the electron densities are Na and Nb respectively. Their respective Fermi wave vector are KFA and KFB. Then KFA is equal to 2 KFB if when this condition is possible. So we have answer for that. Okay, so as we know, Fermi energy is given by h cross square kf square divided by 2m. K is what? Wave vector. So Fermi wave vector. So also we can have the Fermi energy like this equation. Here if we substitute the value of kf, that is 3 by pi square 2 by 3 n to the power 2 divided by 3, then kf is directly proportional to what? This n to the power 2 by 3. Then KFA for A and B. So A if we take KFA is equal to NA to the power 1 divided by 3. Okay. Then KFB is equal to NB to the power 1 divided by 3. But condition is what? KFA is equal to 2 times KFB. Then 2 NB to the power 1 divided by 2 is equal to what? Na to the power 1 divided by 3. So if we take cube of on both sides, then finally we will get Na is equal to 8 Nb. Then the correct answer is option D. So next question, a metal wire of radius r and electron density n is carrying a current I. Then the drift velocity of the electron in this wire is given by. If we read the question carefully, we can have the answer here. So we know that current is equal to what? N into E, A into V. So I is what? Current in both cases. N will also be the same in both the cases for material. Then value of this N depends on the nature of material, okay, charge carriers. Then the drift velocity, as we know, which is proportional to pi 1 divided by pi r square area. Then this drift velocity, if we replace this r with distance 2r, then finally we will have the answer option B. Okay. Application of Hall effect are to find the type of charge carriers in a sample, to find the density of charge in a sample, to find the unknown magnetic field. So all these three actually holds good respect to the semi superconductor. all three given quantities from Hall effect we can measure. First three options are correct in respect to superconductor, but option D is not correct since no particular relationship between temperature and heat capacity in superconducting state exists. So the correct option is here D. All are true to find the type of charge carriers and remaining options. Which of the following is not true? A superconductor is characterized by a persistent current, perfect diamagnetism, existence of energy gap, heat capacity, linear in temperature. So actually the correct answer for this is option D, heat capacity, linear in temperature. All these three we can have the properties. Then the next question, given below are two lists of statements. So point defects, superfluidity, liquid crystals, insulators. If we read these options, B, Misner effect, Fountain effect, then the correct option is D here. So point defects are 3, that is increase with increase of temperature, superfluidity, that is 2, Fountain effect, liquid crystals, 5th, orientational order, insulators, 4th one, large energy gap. So option D. So this is all about the solution of previous year question papers. I hope this video is helpful for you. So thank you for watching and please subscribe my channel.